let's talk a little bit of center of mass. So, there's this thing called center of mass where you could basically take an object, condense it down to one point, and that would be where like all the mass was averaged out. And we can talk about this in the x-axis, the y-axis, and the z-axis. But let's start off, if we talk about it in the x-axis, just horizontally. If we had these three masses, let's say this one is 10 kilograms, this one's over here, so let's also make it 10 kilograms. And so if we only had two, the center of mass should be like right in the middle, and that's what you would expect. But let's have one right here, and let's just say that's about 4 kilograms there. So we got 1, 2, 3, 4, 5, 6, 7. It should be at 3.5 if just the 10s existed, but we got this 4 sitting there. So the 4 is going to make it drift a little bit to the left, and that's what we would expect. We'll see if our result is going to be a little bit to the left of this 3.5 mark in the middle. So, the idea of center of mass is that, come on, Peavy, leave me alone, is that you have the masses and their positions, and you can have 3 masses, 4 masses, 5 masses, you can have however many masses you want, but we're going to sum up all of these masses together and their positions, and then we're going to divide it by the sum of the mass total. And my dog is messing with me right now. Hey, I'm making a video. Sit down. Alright. So what we can do here is we can actually take each mass, and we need to reference a 0 point. So a 0 point for us is going to be right here. So this is going to be what we call 0. This is going to be what we call 7, if we counted that right. 1, 2, 3, 4, 5, 6, 7. Which means this will just be at 3, and we're good. So we're going to take each mass and multiply by their position. So the first mass is 10. It's multiplied by 0 because it's at the 0 position. If I wanted to call this 0, I could. This would be then at negative 3. So 10 times 0 plus 4 times its position, 3, plus 10 times... Sit down. Sit down. Sit down. Alright, 10 times 7. Thank you. And we're going to divide all that by the total mass, which is going to be 24. And if you just rip out your calculator, and we got 10 times 0, which is nothing, so we just got to do 4 times 3, which is 12, plus 70, divided by a total of 24. I get an answer of 3.42. And that's going to be in meters or whatever unit this is, but we said in the beginning that the center of mass should be a little bit left of 3.5 because the 4 kilogram piece is sitting there, and it is. Alright? So this whole idea of center of mass is that you can take all these objects and apply this equation to it, and you can find out where the average of those masses are based on position. And if you had a 2-dimensional object, then you can do this in 2 dimensions. If you had a 3-dimensional object, then you can do it in 3 dimensions. But what happens in AP Physics C is, these masses aren't just point masses. Maybe we have an axis like this, and we can have an object that might be, let's see, how long do we want to make this? Let's make it 1, 2, 3, 4, 5, 6 long, and we'll make it about 1, 2, 3, 4 tall. And so the question now is, if this is a triangle of mass m, then where would the center of mass lie? And if this mass is pretty evenly spread out over this triangle, then you would expect the center of mass to lie more towards this side along the x-axis and more towards this side along the y-axis. Okay, 1 second. Hold on. Alright, do you see this? This is called bear. And PB wants me to throw bear, so I'm going to throw bear. And we're going to continue talking. So this mass is spread out over this triangle. Stop it. And so we need to figure out where the center of mass is. And we're going to guess it's going to be somewhere over here. Alright? And the way we're going to do this is we're actually going to look at this only on the x-axis. And so we said that this was 6. Therefore this is 0. And we're going to be spread out all over here. Now the vertical doesn't matter for the x-axis. We just want to talk about how far away these masses are. And we need to figure out what we're talking about and like what we're adding up. So we're adding up a bunch of masses and their positions. So to do this, we basically need to split this triangle up into smaller parts. And we can say, alright, well this triangle is made up of these trapezoidal things, and they are all a position away from this 0 mark. Alright, so this first one obviously has the most mass. It is about yay far away for its center of mass from the 0 mark. This one has, second most, third most, fourth most, fifth most, but all these have their own positions away from the beginning mark 0. And so you say, alright, well, how many of these could we have to be more accurate? Because we want to find the center of mass for this whole thing. And so you can make as many as you want. And, if you've been paying attention during class, and I'm kind of heading towards something, and that is where we talk about the integral. And we talk about adding up a bunch of these things. Now, how many of these things are there? We're going to have as many of them as possible, but I'm not going to draw all of them because that's crazy. And so we're just going to say, hey, we'll take one of these. Let's say we have this one here. And if we just look at this one here, then it is super, super long compared to how thick it is. All right? And the height of it is going to be along this y-axis. So y is going to be the height. Now what happens with the y here is that the y goes from 4 down to 0, and it takes about 6 over on the x to do that. And that kind of tells us, hey, that might be an equation. That might say that the slope here is negative down 4 over 6 x plus a y-intercept of 4 if we were to make x 0. So if x is 0, then our y-intercept is 4. This is basic algebra. That's the equation of the line. Hopefully we are okay with that. So if I want to talk about this shape here, it has a height of about y, and this is going to be about 1, 2, 3-ish. So if we plugged in 3 there, it would pop out a height here. Now, I really don't care what it is. I'm just saying that we'll use this for the height. The thickness of it is going to be what we call dx. Now the d here represents a very, very small change. How small is like the smallest of the small. That small is probably not small enough. It's like thinner than that. Alright, as small as you can get it. 1 atom thick, I guess. So what we have here is basically this mass spread out over this area, and we got to figure out how we're going to sum up all these pieces to get the total sum of every piece divided by the total mass. Alright, so we think about this and we say, alright, how is this mass spread out? Because there's more mass with these big pieces than these small pieces. So we're going to say that this mass is kind of smeared all over the area of this triangle. Alright, and I like to use the word smear because I used to work in a bagel deli back in college, and Mr. K used to make bagels. That's true. Favorite was the Asiago cheese bagel. Now I can't have it. But this mass is spread all over the area A. And so what we know about this is that this is kind of like density. Alright, if you're familiar with density, density is the mass over a volume ratio. Where if you were to take this ratio, mass divided by volume, if you multiplied it by some different volume, let's say V prime, then we would get some mass out of it. Alright, so we're going to use that idea with this one. It's not a volume, it's just going to be an area. So if we were to multiply this ratio by any area, then we should get the mass. And the area of a small piece would be a d area. Alright, a small area, d area is what that represents. And that should give us a small piece of the mass, in other words, a d mass. Alright, so we've got the mass spread over the area. We multiply that by some area, who cares what the size is, but whatever it is, it's going to give us a d mass. Alright, don't pronounce it like the mass, it's d mass. Alright, so what is the area that we're talking about? Well, the area is this thing. And again, this thing is super, super, super tall compared to how thick it is. So in essence, it's just a rectangle. How do you find the area of a rectangle? Well, for us right now, we're picking the d area to be the area of this rectangle. We're going to take the height, and we're going to multiply it by the thickness. And hopefully that makes sense. That's the height. This is the thickness. That gives us the area. Now, y is actually its own equation. We said that it is negative 4 over 6, or, I don't know, 2 over 3, x plus 4. Alright, that's what y is. dx is still there. And those of you in calculus now say, hey, we have here's our variable, here is our differential, they match up, that's good. And so we're going to take the area. We're going to put it in right there. And so the mass, the little small piece of mass, is equal to the mass of the whole thing spread over the area of the whole thing times a small area, which is represented by this. So it might be astute to say, hey, what is the area of this whole thing? That might be important, and since we have numbers, let's go ahead and find it. The area of a triangle is going to be the base, the whole base, times the height, divided by 2. It's like slice a square in half, or slice a rectangle in half. So we got 24 divided by 2, it's going to be 12. And so here, we're going to say, hey, it's mass, whatever it is, spread over the area of 12. And we're going to multiply that by dA, which is going to be negative 2/3 x plus 4 dx. Okay, so what we have here is now a setup that would give us a small piece of the mass based upon what these shapes are. All right, and we're going to apply that to this formula up here. So in this formula, we're summing up the masses, and the masses are actually small masses. So we're going to take the sum of each one of these little masses times their position x, and we're going to divide that by the total mass m. Okay, now how many are we summing up? Well, we're summing up all of them, all right, however many there are, and we need to replace dm with this. That's what dm is. So it's dmx. So throw back. We got m divided by 12. We got negative 2 over 3x plus 4 dx. And there's an x there in the first place. Let's throw that in, maybe out here. We'll make it look nice. I know I'm off the page. Let me move a little bit. So all that is dm times x. That's dm. That's x. And we're going to divide this whole thing by m. And how many do we want? We want all of them added up, so don't forget that. And so we want them added up. How many do we want? We want the whole thing. So our x goes from a value of 0 all the way to a value of 6. So we're going to range it from 0 to 6. And this looks like crap, so let's go ahead and make this a little bit nicer. I've got an m on top, I got an m on the bottom. That's going to go away. Let's see what else. I've got an x that I can distribute to everything. I've got this 12 on the bottom there, so let me see what I can do about that. I've got negative 2 over 12 times 3 is going to give you 36 x squared plus 4x divided by 12, because that needs to be distributed too. And we've got the x on the outside, and we are adding all of them up, and my pen's dying, from 0 to 6. Okay, let's see. Can we evaluate? Can we make it work? Yeah, we can make it work. We're just using the power rule. So we're going to say, hey, power rule, this is a constant. Let's see, half of 36 is 18, so let's go ahead and just say that we have negative x squared becomes x cubed divided by 18 times 3, because that is what we need to drop down, plus, let's see, 4 over 12 is going to give us a third, so we have 1/3, x becomes x squared divided by 2. And I'm ranging myself from 0 to 6. Okay, and so what is that? Let's see. Pretty good. 3 and 2, that's going to become 6. Don't need to do too much more. Let's go ahead and plug that in. If I plug in the 6, I put a 6 there for x and a 6 there for x. If I plug in 0, this whole thing becomes 0. So it's 6 plugged in minus 0, so I don't even need to plug in the 0. We're going to say that this is equal to negative 6 cubed divided by 18 times 3. I was hoping that something nice would happen, but no, it didn't. Plus 6 squared over, well, 6. Okay. And it's late, so let's go ahead and just use the calculator. Let's see. We got 6 to the cube is going to give us a whole lot. We're going to divide that by 3. We're going to divide that by 18, and that's conveniently 4. So we got negative 4 plus 6 squared over 6 is just 6. So we get an answer of 2. So what does that mean? All this gives us 2 right there. Well, we just figured out the center of mass along the x-axis. Center of mass along the x-axis lies somewhere along this line. Okay, now what's significant about this is that we've come down to a solution that I hope you need to you realize that 2 is just a third of 6, right? So with a triangle, if you wanted to find the center of mass for a triangle like this, the center of mass is just a third of the side. So we can just take a third and multiply it by the side 6, and we would get 2, and that's great, that's fine. But you do need to understand that we went through all this to get there. Okay. Now, using that fact that it's just a third of the side, we can talk about the y center of mass, and the y center of mass would be a third of 4. So we're going to take 1/3 and just multiply it by 4. So we're going to get 4 over 3, or 1.333333. All right. And so 1.33333 is going to be somewhere along this line, and where those two lines intersect, this would be the position of our center of mass. And we said the center of mass should lie somewhere over here. I think I was guesstimating somewhere over here, but we know it now to be exactly at that point. 2 over on the x, 1 1/3 up on the y, and we used calculus to get there to end up with basically this algebraic shortcut. But this is how we would use calculus to find the center of mass for a triangle of of uniform density. You can do this for any kind of shape you want. You just need to know the formula that you're working with. We'll stop here.